In this video, we will see sinusoidal function by its graphical representation. So let's understand this by an example. Let's take v of t is equal to Vm cos omega t plus phi, where this v of t is the sinusoidal voltage, Vm is the amplitude, this is the amplitude or maximum voltage, this cos is the function, omega is the angular frequency, it is angular frequency in radian per second, this t is the time in second, and this phi is the phase angle, it is the phase angle, and this represents sinusoidal voltage. We have to represent it by graphical representation. So in graphical representation, we know that the graph will look something like this. It is positive cos omega t and this is negative sin omega t, and this direction is the leading direction, it is plus phi, and this direction is the lagging direction, it is minus phi. Here we can write this is leading and this is lagging. Now let's understand this by an example. So let's take an example. Phi u v of t is equal to phi u cos 40t plus 20. So solution for this will be, here we can see amplitude is equal to 5 volts, and this angular frequency is equal to omega is equal to 40 radian per second, and next is this is phase angle. So phase angle is equal to phi is equal to, it is 20 degree. Now from these values we can also find frequency is equal to f, and we know that omega is equal to, we know that since omega is equal to 2 pi f, so f is equal to omega divided by 2 pi. Omega is equal to 2 pi f, so therefore f is equal to omega divided by 2 pi. Omega divided by 2 pi, the value of omega is 40 and it is divided by 2 pi. So 40 divided by 2 pi, this will be 6.36, and the unit of frequency is hertz or cycles per second. We can also find time period. Time period is equal to t is equal to 1 upon f. So if we divide 1 by 6.36, then this will be, we can write 1 upon answer. So it is 0.157, and the unit of this time period is second. So now we can represent this sinusoidal function by its graphical representation. So again, let's draw the graph. So on this x-axis, this is plus cos omega t, and on this y-axis, this is plus sin omega t. Now here we can see the amplitude is 5 volt. So let's draw a circle of radius 5. So let's say this is 1, this is 2, this is 3, this is 4, and this is 5. So the circle will be something like this. And this radius is, its radius is 5 volt. Then the angle, here we can see the phase angle is 20 degree. So from here we have to draw 20 degree. So from here to this will be 20 degree. The value of this phi is, here we can write phi is equal to 20 degree. This is the phase angle. This is phase angle. This is amplitude. This is amplitude, and it is rotating in counterclockwise direction. So it will be rotating in this direction. Now next is amplitude, then phase angle, then angular frequency. So angular frequency is 40 radian per second. That means from this angular frequency we can find frequency, and then from frequency we can find time period. So time period is 0.157 second. That means it will complete this one cycle in 0.157 second. So this is the time period. So this is how we can represent sinusoidal function by graphical representation. Thanks for watching.